Well, hi, and thanks for joining me here in my shop. It's been a few days since I've been here. I've been on vacation and took a trip to the city of Ottawa here in Ontario. A wonderful city, well worth it. Well worth visiting. So, last thing that was happening here was I was facing a decision to take out the IF can that's located right here, wired in over here. And I'm very hesitant about doing something like that. I mean, it's not the end of the world to take it out. One simple approach is desolder all the wires here. I shouldn't say simple. Disconnect all the wires here. Take the holding screws off that I've put back on, by the way. And then just pull the whole thing out like that. Will come out can and guts all together. And then I would face the same problem I'm facing right now, which is to separate the can from the guts. So having removed it in itself wouldn't improve the situation. Now, why, in that I would still have to remove this can. Now, as it turns out, I think I can get the can off without doing all that desoldering and rewiring. All that has risks associated with it. Everything of course has risks associated with it. So you see, I threw a little piece of tape on here with two arrows. This was to remind me when I came back from vacation what it was I spotted just before I left. And that is, the can here is held onto, you can see the form sticking out here. It's held onto it by simply a little bit of aluminum being bent. Little aluminum tabs bent. I can see the tabs here. So I think there's a chance I can get in there, bend those tabs back. I'm going to have to do it anyway. Even if I remove the whole thing, I still have to bend these tabs, although it would be a lot easier, no doubt about it. Once the tabs are bent back, I think the can will slide right off the top. So let's see. So now, aside from all that, oh, my tape has come off here. There's some cats in here. What's going on? So aside from that, I still have the question of whether it's worth even doing this. What I'm going after are a couple of what are probably mica capacitors that, in my experience, are extremely reliable. No, they aren't perfect. They do fail. I have come across them. I have come across open ones and I have come across shorted ones. So it can happen, but usually the symptoms are very dramatic. That's just been, my experience and the journey I've taken through this. There's one case where I searched long and hard for why a radio didn't work. This a long time ago, a very complex ham radio, in fact, ham radio receiver. And I kept skipping over the mica capacitors, and finally I started looking at those, and sure enough, it wasn't long before I found a bad one. And that was the whole problem with that radio. So it can happen. So I think the logical way to go is to try to get this can off. Back up, there's still another step. Is there any way I can determine for sure that the capacitors are bad in here, have gone off their rating, or whatever it is that's happened? I guess another kind of remote possibility is a short has occurred in one of the windings of the transformer, and the short circuit has in effect reduced the number of turns in the winding. And this would change its inductance and therefore change the resonant point of that coil. So that's another possibility. And it is possible to make a resistance measurement through those coils. And I think I do have coil resistance numbers here somewhere. I do, right here. Now, things like 10 ohms, 10 ohms, 15 ohms, 15 ohms. Well, that's certainly measurable. But, if let's say it's, which can is it? It's can number 2, it's this one. Let's say I decide, okay, let's measure the resistance. And so if 10% of the turns are cut out from a short, what's this 15 is going to measure at 14? What am I going to say? Am I going to say, oh, that's definitely shorted? Or am I going to say, look, they put 15 there, 1.5. They didn't put 1.4.298. They put 15. So it's not that precise a number to begin with. So I think that's a bit of a dead end. Okay. What I'm going to do is I'm going to try to take this can off just by bending these tabs. And we'll see what kind of a horror story that turns into first. And if that turns into a horror story, well, we'll take alternate plan 7B. I have to make that up first. Okay, so I think the first smart thing to do is take a little closer look at this radio. Colburn Street, Brantford. I'm going to, let's see. I'm going to max up the zoom here. There we go. Now we'll take a look. We'll take a look and see what we can see here. So see, I don't think there's a lot of aluminum bent there. That looks like a real easy thing to bend back. That looks really easy. What about the yellow one? So there's a little more under that one, but the same thing. It looks easy to catch it, and we gotta assume the other side is the same. I got a tube here in the way. Ooh, doesn't that sound good? And the other side's gonna be exactly the same, just a little more awkward to get. That doesn't even seem to be bent. Look, they didn't even bend that one. So I just, lucky break. Only 3 to do. So I think if I bend these 3 tabs, for sure, we're going to try that, for sure. Off will come the can. Now, some of you may have dropped comments and ideas and stuff like that on the last video or previous videos. You may have dropped excellent ideas that I really should know. You might even wonder, why is he not doing what I said? Mostly it will be because I didn't read the comment. And why is that? It's a complicated answer, but there's a very good answer for why you don't read too many comments. There's actually quite a few answers to that. So, it's not that I don't appreciate comments people make. I do. Oh, this is bending easy. That was easy. And the discussion that goes on between different viewers like you and others, and guessing at what might be the problem and all that kind of stuff, that's all great, even when I don't avail myself of it. Okay, that's really hard to get a hook on that. So if I get 3 of these, maybe the can will come loose enough I can kind of get in there a little tighter. So let me try the other side now. Give it a go. Yes, Ottawa, capital of Canada. Wonderful city to visit, no doubt about it. Lots of museums. You got all the government, parliament buildings. You just got tons and tons of stuff. One thing about Ottawa, though, you don't want to drive around in Ottawa. If you're going to drive your car in Ottawa, better practice some calm breathing. No, I don't think I'm going to be able to do it with this tool. I'm trying to hook it and then do this. I bent something. What did I bend? Oh, I know what I bent. Oh, wrong end. We're using the wrong end. Let's use the better end here. This isn't very strong. This isn't strong enough. They need a stronger one. I don't know if I can get this in there now. Oh, this wasn't nearly as bad as I had expected. I thought bending these out would be... Hey, it's not coming loose at all, though. Uh-oh. Coming out loose. It's as solid as can be. You know what? I think it's locked down from the top here. How's that possible? That's not really possible, is it? This is going through a threaded piece that's in the can here. That doesn't make sense. That doesn't make sense. It's going to say, if this is threaded through the can, then you'd have to push this down through the thread. But they don't make them that way. What is going on the top here? Let's take a look. Let's take another close look here. Usually there's lots of gapping up in the very top. Wow. What is going on there? So all they've done is taken the metal can, punched it downwards, and it is coming through the actual metal can. So I thought this part here was an internal part, and it was just... Wait a minute. Is that all one piece of metal? So it's certainly bent down to here, but then this is something else, isn't it? It looks like there's an understructure. So what it looks like now to me is this top part has been depressed into this shape. But there's another piece coming up, like an internal sleeve. You can kind of see it in there. It's probably part of the structure underneath. So I just kind of imagine they would thread this through the can as the primary threading, you know? I think they would thread this through something that's held in position relative to the coil underneath. So it had some kind of internal structure. It's got to. But let me wiggle the can here and see if anything. I can't see a darn thing move. This can is as solid as can be. I think it's glued in down here. Oh, so there's something more going on. I haven't got the picture right. Let's just take a look under here again. So anyway, I thought I bent that one out. Okay, let me go after this one again. Maybe all that's happened is I really haven't loosened it off yet. That's really all that's just happened. Thought I was more successful than I was. Bending the tab. Put the power tool on it. The power tool. No, there's just nothing to grip onto here. So it looks like, in fact, I may have actually bent the tab up even tighter. That's really what it looks like now. When I'm doing this, I'm wedging this tool against the can and the brown material here, whatever it is, and surely to goodness that brown material has its limits. If I use it like a fulcrum, I'm going to crush it, I think. I crush away a bit of it and then the tab will fall. It won't even matter. I'll never get the can on tight again. These are the things. Let's take a close look at what I'm doing here, because maybe I often find when you look at things from a distance and then you look at them up close, holy smokes, doesn't it look different? I think that'll work. Okay, how about a little focus on that? It sure looks to me I should be able to drive this tool. Looks like an easy thing up in through here. Down in behind. Okay, I'll try coming up from below. Got it. I don't think I just don't have the angle to bend it when I'm pulling this way. I need an angle on it. It's about a 4-hour drive or so between here and Ottawa. The whole time driving through the middle of my province, Ontario. That's the roads that my wife and I like to drive on. We kind of stay off the super highways. Drive on the lesser highways. All across Ontario and all across Canada and North America, everything you see pretty well is the results of glaciation. Every little hill, every little this, that, and the other thing. It's all because of glaciation. It's only been around, like what I live in and what I see, it's only been around about 10,000 years. So driving between here and Ottawa is like driving through geologic history is not quite the right word. It's so current. All these hills I've been seeing all my life now have taken on a new definition of remnants of a glacier and the aftermath. The huge rivers, this isn't going at all. The huge rivers and lakes, temporary things that form as the glacier recedes. Things form, huge flows, unbelievable flows of water at times. Coursing across the land, rivers, 50 miles wide, stuff like that happening. And then, so I drive through the remnants of all that. I find it a lot of fun, actually, thinking about it. There are a few locations where, like, it's a heavily farmed area, of course, so there's farms everywhere. There's not an awful lot of completely undisturbed land that's actually, been sitting there for 10,000 years and no one's gone and made a farm on it. Am I getting anywhere with this at all? Look at this thing, it's as solid as a... Oh, you know why it's solid? I put the bolts back on it, you knucklehead. Yeah, knucklehead. I even said that earlier, I screwed the nuts back on it. Okay, get the nuts off here. I'll just do that off camera, just take a second. I get denut it. Okay, one of my little nuts went bouncing away. Don't worry about that later. Now it's a little loose, Jim. Okay. It's got to be loose relative to this thing. Solid as a rock. Well, if this doesn't go well, I just have to take the whole can off because there must be something more I'm missing here. Because I've never had one this solid. Decision time. Since bending these tabs doesn't seem to have released it at all, even if I wedge up in here. There must be something more going on in here. I'm just not getting it. So maybe it does involve screwing this all the way down. Maybe I gotta whack it down. What do I tap it a bit? Maybe it's just so jammed here. I'll give it a little tap. A little tap can't hurt. What would I tap it with? Tap it with this. I'm looking for clearance to develop here. Nothing. I don't want to whack it any harder than that. I'm just exhausting all the low impact options one after another. I can get in here easier now. I can get a better look at it. Let's get a better look at it. Hey, Jim, you're getting all excited. So as usual on these long trips, I usually have a driving event. All the driving's nice, and then there's one event. I had an event coming home with my wife. I'm going to tell you about an earlier event I had which I may have mentioned the last time we went to Ottawa. On the way home, we're driving through Algonquin Park. Algonquin Park is one of the largest parks in North America, if not the largest. It's huge. It protects the headwaters of all the rivers and lakes in a great deal of Ontario. We're going through this park. It's a windy, hilly park full of trees, and not little hills, sudden, steep, cliffy sort of hills. So you're up and down and all around. You're often driving down a road with a bend up ahead. You can't see around the bend. You're only allowed to go 80 kilometers. But people like to drive 100 during the day on a road like that. So I've learned, this is what one of my driving, here's a driving thing. You look for pressure in the traffic. Let's say you're driving down the highway and you're all by yourself in one lane, but in the other lane, and then you see this all the time, in the fast lane there are 3 or 4 cars and they're bundled up, like they're having their own little traffic jam going down the highway. 4 cars because of the nature of the drivers in those cars. And that's pressure. One of those drivers doesn't like it. Actually, none of the drivers like it, and all of them want something different to happen. The guy in the front wants the guys in the back to take off. Guys in the back want the guy in the front to get out of there. On a multi-lane road, this isn't a big deal. Sooner or later, somebody will break out of the pack and go around or something like that. The pressure tells you somebody is thinking about doing something. They're all thinking about it. Something's going to happen. So if you're a driver driving along near a group of pressurized vehicles, you should think about that a little bit. So here's my story. So being well aware of the pressurized vehicle thing, as I'm going, so you picture this road as, in many cases, you come around a curve and then there's a straight for maybe 500 meters, 1,000 meters, like a kilometer, and then there's another curve and it disappears off. You come around the curve, you see the straight. No cars anywhere. You drive along, you're about a third, this is my story, about a third into the straight, and the first car comes around the bend up above. And right behind him is another car, and another car, and another car. I'm saying to myself, here comes a pressurized group of drivers. Now I'm halfway through the straight part. And sure enough, when the 5th car comes around the bend, he's not in that lane, he's in my lane. He's in the middle of passing. In the middle of passing, he's come around the corner and discovered that 300 meters down the road is me coming at him at 90 kilometers an hour. He's outside this line of cars. So think about it. Are they going to let him back in? Are they aware of what's happening? What is going to happen next? So I instinctively hit the brakes, slow the car right down, and finally I decided I'm going to get right off the highway. So it's all an emergency move. I'm not having a casual time of this. My wife's kind of yelling. So I bring the car right down, yank it off the road. I really don't know if the guy got back in the lane or not. All I know is there was a lot of dust and nobody got in an accident. Now here's why I'm telling you this story. Because the dream comes true. I look in my mirror and one of the cars in that string of cars is a police car. And his lights have come on and he's going after the guy. And my wife and I I'm almost got tears in my eyes right now telling you this story. We were so excited. I'm telling you, look, I'm getting choked up. So, you know that thing? Where's the cops when you need them? Right there. So I think that guy would get charged with either, he'll probably get initially a heavy charge and then get a lighter charge. He'll probably get something like reckless driving or careless driving or failing to pass when the way is clear, or whatever it was, I don't know. But he basically drove us off the road. Okay, I'm all wound up. I'm going to do the next story. Yesterday, coming home from Ottawa. We're driving different highways, but it's the same kind of country. So it's up and down and all around. Speed limit is 80 kilometers. We're driving 90. It's during the day. I feel safe enough at 90. People want to go 100. I don't like 100. Up behind me comes a big transport truck. Next thing you know, he's not just behind me. He's right on my bumper. I've never seen anything like this. I'm in my 60s. I've been driving since I turned 16. Never have I had a vehicle, especially a big transport truck, come right up behind me. I couldn't believe it. He wants me not to go 90. He wants me to go 100 or something like that. Well, I'm not going to go 100 because then he'll want me to go 110. And 100 is dangerous. I'm not going to go 100. And the proper thing to do in a situation like this is slow it all down. Oh, that's irritating. But sorry, Mr. Truck Driver. If you're going to drive about 4 to 5 feet, I'm serious, behind my bumper at 90 kilometers an hour, no, that's not happening. Because if I have to brake suddenly, you're going to hit me. So I can't let this happen. I'm not going to speed up because you're just going to chase me down the highway, and we're going to all be driving above 100 in a dangerous curvy highway. I'm not going there. So I slowed down even more. And the guy just went wild. Horn going, hands waving, swearing. I'm sure he was swearing. I can see his teeth, for crying out loud. He's right behind me in my mirror. I can see everything. So then, dotted line, okay, you pass. I pulled my car partway off the highway. I'm not going that fast now, maybe 40, 50 kilometers an hour. And the guy is forced to pass me, and off he went. You know what? Here's the thing about that. Is I was unsettled for almost half an hour after that experience. I couldn't stop thinking about it. Look, I'm telling you about it, for crying out loud. I couldn't stop thinking about it. I couldn't stop having conversations with that guy. I was making all kinds of stories in my head about seeing him in a restaurant, give him a piece of my mind, and all that kind of stuff. Meanwhile, I'm not driving all that well. So, wow. Okay, sorry to tell you that story. You've all got stories, I know. I don't even know why I bothered telling you. I'm just upset about it. So, and afterwards, after it's all over, I'm sitting and reviewing everything I did and thinking, you know, I could have taken other actions. I could have chosen to drive faster. I could have done that. Okay, now I'm going to get comments on driving stories, which is fine. But I'm sorry I kind of went off the rails there. But, you know, there's almost nothing that threatens us more in life than driving our vehicles and other people driving theirs. So, but just to be intimidated by a transport truck on a windy road, wow. Now I'm going to rip this right off the radio. So I don't know what to do. I'm going to have to disconnect the wires, lift it right off. I just don't see any alternative. So I'm going to work away at that. I'm going to calm myself down. I'm going to consider removing this part of the video. And yeah, I got to calm down now. Look at me. Oh my gosh, I'm back in my car again. So I think what I want to do here, just before I make a big mess of things, is really verify that this is done correctly. There's my resistor here, there's another guy's capacitor there, and there's another capacitor down here. Just in case there's something that, you know, I'd hate to take this whole thing apart and then conclude there was no reason for doing it. That's where I'm at here. So let's look at this diagram here. Okay, let's try this. Okay, now item by item by item. So this resistor here is this one, starting there, yep, and going to there. This is 1, 2, 3. You can't see it, but it's under there. 1, 2, 3. That's correct. Of course, it's correct. Off of here is 1, 2, 3 more leads. 1, 2, 3. One is to this resistor. Yes, this R9. Great. The other one's a red wire going somewhere, which it is. Okay. It's really these new components I'm worried about. Here looks like a green wire. Green wire going there. Yeah. This guy. This big capacitor's got to be C16. C16 is going to the center pin. Oh, okay. So it's not quite laid out the way it is here. Here they show them in a pretty much a straight line, but in fact this terminal is in quite a bit. It's way in here. Does that matter? I don't think so. I think it's done correctly. C16, and then the other end of it goes to the cathode, which is just a grounded terminal. Right on. And it's supposed to be a 0.0. Well, this is a 0.056. This one, and it's supposed to be what? C16. Let's just double check here very quickly. C16. Can we see 16? C17, C16, 0.05 microfarad. So it's a 0.06 in there, or 0.056. That's good. I double checked it before, but no harm doing it again. Now here's a little tiny resistor R8 down there, which I've looked at, and another one right here. Well, that was R10 and R8. Those haven't been moved or anything, so R8 is this one here. Now underneath, it's really hard to see, is a capacitor down here on those black ones. It's right on a lead. It's right on, I want to be more specific, it's right on one of the inductor capacitor terminals. There's 4 of them, right? And then these 2 are fakes. Fake terminals. So, you know, could it be the case? And this is grounded. This is C20 heading to a grounded terminal. I just don't see how that can throw the resonance off. But then, now there's another black capacitor right here, but I think it's just part of this. It's this one, C45. That's busy on the tube socket, but you know what? It is kind of tied back a little bit. This is a grounded terminal. All these are grounded here. That, all grounded to here. So this is a capacitor off the plate going to ground. I just don't think the capacitance is outside of the one that's actually paralleling the coil can really throw off resonance. Okay, so trying to measure the coil resistances. What if we try to do that? So a coil here is this L. Between here and here is a coil. What else is between here and here? Okay, so this terminal goes nowhere but to a tube. So we should be able to read the resistance of that. We'll have a capacitor in parallel with it, but presumably the capacitor's resistance is way higher than 10 ohms. So it shouldn't have any effect even if it's leaky. So I could measure these resistances now, that resistance rather. Now what about the other side, L11? Okay, so if we follow, is there one terminal? This one has only one wire on it, and it goes to a tube. So if I pull these 2 tubes out, and these are the plate wires. I think is this one the plate wire? Green, probably not. Green usually means secondary grid or something like that. So, but in any case, pull out this tube, both these coils are then free to be measured. I can measure both their inductance. I could attempt that. At that point, why can't I actually measure the resonance of these individual guys? Why can't I? And I don't have a resonance meter. I mean, it's not that easy. It's not that simple. Let's do that. We'll do the resistance here before I muck this whole thing up. We'll do the resistance test, and then we can scratch our heads like I suggested earlier. We'll end up just scratching our heads over it. Okay, now pull out the 2 tubes, and one of them's already out. I'll pull out the other one here. Come on. Okay. Now, to measure it, I would like to use my most favored little meter, which, where is it? Where are you? So my favorite little meter's not here, but we'll use this one, my less favorite meter. This auto ranging meter digital thing really drives me nuts. But we're going to try it out. Okay, so these very short leads, but they have clips on the end, so that's why I like these. That's one end. Okay, what do we got? .2 ohms. And what does it say? So this is IF number 2. We are on the we're on L11. L11 should read 15 ohms. So here we are. So, you know, what do you do? what do? You break down and cry. Let's measure the other coil, and if it comes up at 15, as denoted here, then maybe we can assume the primary coil has a short in it. Ay. Then we're going to take some other kind of approach to repairing it, I think, then. Trying to fix the coil. Yikes. That sounds like a pretty dangerous road to go down. Must be alternative ways. Okay, here we go. What do we get? Even worse. 10.7 instead of 15. This is exactly what I thought would happen. Let's see, the reading is lower than expected, so you can't imagine there's some kind of resistance interfering with it. There's no like additional resistance. I'm asking myself, is this measurement valid? So if there's anything in parallel with it at all, we would get a lowered reading. There shouldn't be anything in parallel with it. Except, you know what's in parallel with these? The capacitors are in parallel. The ones that are inside the can. Can they leak that bad? I don't know. Now what am I going to do? Like basically a short circuit, 12 ohm short circuit across a capacitor. How can I possibly get any more information out of this thing? Let's try this meter. I'm not expecting any revelations here, but let's just do it. You know, these are all things that are low impact, virtually no risk, just embarrassment, risk of embarrassment, time wasting. Okay, L11 with its capacitor. What do you say? Well, it says it's a, there's the resistance, 12, and it says it's an L. Hey, there's a little picture there of it. I never noticed that before. 2.49, 2.5 millihenries. Is there any chance that information is available somewhere in here? Let me write it down. 2.5 millihenries. Can't remember that? 2.5 millihenries on the primary. Just 1 second here. 2.5 millihenries or microhenries? Microhenries. Wouldn't that be microhenries? mH. Well, I think that's millihenries. 2.5 millihenries. Mr. Henry, you'd be proud. I'll try the other one. You know, there's a capacitor across this, so surely this reading is all messed up by that. Isn't there a capacitor? Could it be the capacitors aren't in there and somehow I just failed to see them in the under the chassis? Here we go. 2.3. 11 ohms. So very similar resistance readings. No surprise there, I guess. And 2.3 millihenries. I've never done this before with this instrument, this kind of thing, so, you know, there could be all kinds of unknown problems here with what I'm doing. 2. Yeah, right. It was the same, wasn't it? Give him another test. Always test twice. I say test twice, change your tube once. 2.3. Almost the same. Would that be surprising? So apparently the typical thing in these IF transformers is the number of turns in the primary and secondary is the same. They're one-to-one transformers, typically. So I guess you'd expect them to read the same inductance, I guess. Okay, now what do we do with the 2.5? What can we do with that? So when you look at the parts list here, and let's see. That's not on the parts list. There it is. Parts list. So we're looking at the IF reproducer, some keyboard, miscellaneous assemblies. Loop antenna marker, spring knob, tool keyboard setup tool. Oscillator coil, coils here, coil antenna, coil oscillator, coil L18, no, these are different coils. L56, no, L11, here we are. Here we are. Yeah, transformer, second IF transformer. Oh, it doesn't give me any factors about it, it just gives me the... That didn't help. There's no factors. I need factors. Somebody give me a factor. It's a bit of a long shot. I mean, this stuff is written on some of these. Did I miss it? Stuff like that on here, did I? Oh! Primary, first, no. I don't know where I would get the expected inductance, even though I'd measured it. So here we are. Now we're really in a quandary. So the measurement comes low in resistance for both of them. So, okay, so what can happen to these things? The most likely thing is a heavy primary current. A heavy current through the primary coil because it's attached to a plate circuit. So a fault in a tube, some other kinds of problems can up the current flow through the coil. And heat the coil up to the point where some kind of short circuit failure, breakdown of insulation or something occurs. Did that ever happen? I'm looking at this resistor here, which has a brownish spot in the middle of it. You know, that's evidence that this guy took a whack, but he's way over there. He's not over here. And that you know, sometimes if you're going to cause a short circuit or a heavy current somewhere, it's going to be 2 or 3 components here and there that are going to take the heat. Well, I'm just trying everything I can think of. So if we're gonna take it out, so this resistor can stay, that resistor can stay, this capacitor's got to come off, this one's got to come off, that's got to, all these wires down here got to come off. So this is the problem terminal here. It's got 4 things on it. The rest of them are all, it's really not too tough. It's just this one. And one of them is my own resistor. It's going to come off easy. These wires are stiff as can be. Oh man, okay, I think the only thing I can do is take them off. Take the can out and see what's going on with it. It's a very unusual little fitting here. You know, this looks like something you could pull off. Looks like a little springy piece of metal that's been snapped on here. And you pop that off and the whole thing comes apart. How can that happen? Can't see that would do anything. Okay, that was just my last ditch attempt at avoiding the removal. Okay, I'm gonna have to work away at that. Yeah. Okay, so removing those, you know, I'm right to go after the tough nut first. Removing those wires has become really quite impossible. I just can't get them. I mean, look at it. I just not without doing a lot of other damage, I'm pretty sure. So what I'm going to do First of all, one of these is the resistor I put on myself. Beep. This great big resistor here. Just gonna have to cut the lead. I just can't. Once I have this out of the radio, I can clean these terminals right up and make them all nice for putting stuff back on. But that's all gonna have to be shortened up. Not good. Now the two stiff wires. So I was fiddling around off camera trying to remove the solder with a solder sucker and everything. Just getting nowhere. So you know when these wires are put on in the factory, they're put on to not come off. You know, they're not just tacked on. So getting them off a terminal like this, you know, like untwisting them, is pretty darn tough. Okay, so that's that. Now there's a couple others here. I think I can. I'm still using this chisel tip on this soldering iron. It's not quite the right tip to be using. Very hard terminals to heat up. My soldering iron is not at the temperature it claims to be at. It's 355. So it's just not putting enough heat into the work here. Counterintuitive. You have to add more solder to get rid of what's in there. Okay, baby. I got anything on that? Nothing at all. You can smell a lot of burning from having the heat on it too long. So that's just not going to work. I have a vacuum solder sucker. It just comes with a million maintenance problems to try to use it. Okay, we're finished fooling around. We'll just deal with the problems as they come afterwards. I need to replace some of these wires entirely. This guy's tacked in. Try another one. Let's try another one. What was that? Anybody hear that just now? It was a crash of some sort. I thought this was tacked on. So I have two new tips for my soldering iron, but I don't want to put them on until I get a temperature gauge. Okay, this guy's got lots of extra wire too. I'm going to be replacing these two black capacitors, so cutting them away really doesn't mean anything. I'm going to probably replace I'll replace the resistors too. You know what? This whole thing's going to get fixed right up. Okay, I think I didn't cut all the wires yet. There's one more here. Ah, wow. Missed one wire. Okay, here it is. All that trying to avoid taking it out, and here it is. Out. Okay, come on out. So we got to bend those taps. That's what we got to do. Looks like it's really just this one. That's easy now. Here it comes. It doesn't have capacitors. What's it got in there? Oh my gosh, it's got open capacitors. Okay. I think we know where the problem is. It's got open style capacitors and it's full of dirt and dust. Open style capacitors. Wow, any corrosion in there. Let's get a real good look at this guy. The last thing I'm going to do today is just take a real good look at it and then make a decision around how to approach this. But I think the decision's pretty clear already. Okay, close-up camera, please. And here it is. So you see the two windings. Look at how fancy they are done. Hey, they're very carefully wound, spaced out. And that is probably what they call Litz wire. Yeah, if you look, it's probably hard for me to point. You can actually see that this wire right in here, you can see some stranding in there. So I believe this wire is actually 2, 3, 4 strands, each one individually insulated from the other. I think. Even though, look at how tiny it is. I mean, that's a pen there. Of course. That was exciting. Now, how about the capacitors? So there they are. There's one of them. So this is an open style capacitor. I've come across these actually tucked in the back of radios, like in the chassis. They have proven to be quite reliable. But look at the dirt here. So, you know, would you really think this would be good? Another thing that can happen is with a little bit of moisture in a long time, you get a little corrosion, and the leads can come off. These don't look. We wouldn't get the resistance readings we got before. So this is the problem. And you know what? The other IF is built the same way. It's going to have the same stuff. Now the solution here is easy. Figure out what the value of those capacitors are, and replace them with a mica, a solid cased mica. I guess the thinking here was you could put this in. It's inside of an aluminum can. It'll never get dirty. No. We're still going on the assumption that there's a problem with these. That's still an assumption. With this out, I can actually set this up, feed IF signals through it, and pick them up on the other side, and do all the adjusting and everything with this out, like this. I can experiment with it. So the resistor there is going across between the dummy terminals. Are they really dummy terminals? See, they come up inside, but nothing's hooked up to them. This side too, eh? So these are spare terminals. Probably in some cases these coils have more going on inside and the terminal becomes useful. But on this radio it's used as a spare terminal. So that one resistor going across there could just be left. And the other one, well, it's essentially going nowhere, right? If you start on this corner pin and trace through the resistor, it just goes nowhere. It's an open circuit. So I can easily set this guy up, measure his resonant point out of the radio. That's the next thing. That's the next thing, but that's for tomorrow, because today is going to be sunny again, or at least nice out, and I'd like to spend the rest of the day outside. So that's good enough for today, though. That's quite the journey. Okay, we kind of ended up in the place where I didn't really quite want to end up, which is cutting all the wires and kind of brutally extracting it, but we had to do it to discover what kind of capacitors are in there. So I think there's a 90% chance the replacement of those capacitors will restore the resonant point of this coil. 90% chance. Not 100. Okay, so thanks a lot for watching, and I hope you enjoy your day, and tomorrow we will pursue this a little further and see what we get. Thanks. See ya.